Hi, thank you very much for coming along. We might start now. Hi, I'm Laura Jones. I'm here as one of the ANU test service architects, I suppose. This session today is an online tutorial for people who are building CSIP-AUS compatible clients. This will provide a bit of an overview of the testing and certification framework and process and the usage of our tools and witness testing. We've recorded this session. We will put it online later this week as a bit of a reference for people who couldn't make it along today or to our event later in the week. By way of agenda, we have 3 things we're covering today. We have an introduction, which I'll give, which will talk you through the processes and procedures. Then Mike is going to take you through self-service testing using our test harness, Cactus. And then Mehdi, our lab manager, will take you through witness testing and those processes. So I'll start with the introduction. So the ANU Testing and Certification Service aims to be a nationally consistent testing and certification service for CSIP-AUS. It's an upgrade from the previous service, which tested 1.1a of CSIP-AUS to 1.2. And the aim is that over time we can reduce or remove distribution network or server operator specific testing and harmonise all testing under this consistent framework. We've modelled our processes on the previous SA Power Networks testing process. So for those of you who have done SA Power Networks certification testing, we expect that the framework will be very familiar to you. So this is the timeline. This deck was made for Wednesday, which is why it says go live today on 1st of October. So 1st of October is our go live date for CSIP-AUS for our service. So from 1st of October, all CSIP-AUS testing goes through the ANU framework, and the South Australian Power Network service will stop accepting applications. The South Australian Power Network service will close completely on the 1st of November, so people who are still in the testing process are able to continue until the 1st of November. So that's the timeline. Just as a bit of a flag, do I need to retest my 1.1a compliant device with 1.2? The testing we've had so far have found that most clients who are compliant with 1.1a are not compliant with 1.2. So, and the reasons that they're not compliant are variable depending on the particular client in question. So at the moment, we don't have a framework that would enable us to do a smaller subset of tests on a currently 1.1a compliant device. So yes, at the moment, you would need to test and recertify for 1.1a capable devices. This is an overview of the client testing process. So this is very similar to the SAPN approach. So when you have a product to test, you can sign yourself up to our test harness called Cactus and undertake the Chapter 13 tests of TS5573, which is the standard that contains the test procedures for CSIP-AUS version 1.2. You don't need to talk to us when you do this. You can do this entirely by yourself, but you can email us for support if there are any issues or things that you're not sure about. The Cactus test harness has inbuilt help that will hopefully help with a lot of the technical questions. TS5573 is freely available on the Standards Australia website, and we have a manual which will be available on the csip-aus.org website. Once you have finished Chapter 13 tests and you have green ticks against all of the Chapter 13 tests, you can do witness testing. So to do that, you email us in the address that I will share with you shortly, and then we can book a witness test. As part of this, we will check that you've passed all of the Chapter 13 tests before we book it. Witness testing is in Chapter 14 of TS5573, and there's some in Chapter 15 for DREAD clients, but we don't know of anyone using DREAD clients at the moment, so we don't expect there is much need for that kind of testing. When we have a witness test, this will happen much the same as the SAPN tests. So we will connect with you online. You have an independent power meter that you can share results with us. We will run the Chapter 14 tests and verify that the client does what it should. And I do wish this reminder would stop coming up. Once you have passed the witness tests, we will create a certificate that we will send to both you and the CEC. The CEC will list it from there. Now, the Clean Energy Council is currently updating their listing process. So currently their listing process is a bit limited in that it is designed for generation clients compliant with CSIP-AUS 1.1a. So, for example, it doesn't have the capability to list which test classes a device complies with. I'll divide out the devices into different modes, into different compliance classes. In the short term, we will list compliant devices on CSIP-AUS.org until CEC update their process, and devices that are compliant with the generation classes will be listed in the same list as 1.1a capable devices. You can access our test service through these two links. So our Cactus test harness is available for free for anyone to use at cactus.cecs.anu.edu.au, or you can scan that QR code to go to it. Our front door for all inquiries is the ccpols.cert@anu.edu.au email address. So when you want to book a witness test, if you have any issues or you require support, email that inbox. And if it's, for example, a bug in Cactus, we will forward that on to the appropriate internal software developers who can fix issues. There is a website on ccpols.org that contains documentation and information on the process, and we'll update that further when that service goes live later this week. One of the things that's on that website is a manual that contains all of the information about how the service works. Now, one thing to remember is that this is a new service. We are testing it or building this service and using it for the first time. There will potentially be teething issues or software bugs. If you see them, please email us and we will rectify them as quickly as we can. Now, just a couple of FAQs before I hand over to Mike. First is issues. So we've already observed in some cases that there are some examples where TS5573 is a little bit unclear, or there are some issues with it. And we've built this issue management process for us to surface these issues and deal with them in the most appropriate way. So if you have issues, email the inbox and they will run through this process. So the idea is, if they're small issues, for example, software bugs, we can just fix them ourselves. But if they're issues that impact other people, so for example, we're changing a test definition that would mean that clients or servers need to do things a little differently, we've got a process we use to identify the impact of that and then use the appropriate method to resolve those issues or approve the change. We've had a few issues already that will run through this process over the next little while. Another difference between our test service and South Australian Power Networks is that South Australian Power Networks service was designed for generation clients. We can test all classes that are in TS 5573. And this is a list of all of the classes, which is a fairly imposing list. But it is actually a bit simpler than that. These classes kind of connect together into baskets that you use to certify different kinds of devices. So, for example, a generator uses the A, DERA, G, DERG, S, and M if they have multi-DER support classes. Loads are A, DERA, L, DRL, S, and M if multi-DER supported, and there are similar mappings for the DREG classes. It is up to the client to choose which classes they certify against. You don't need to certify against all compatible classes. So, for example, if you make a battery, which could certify against both generation and load classes, you may choose to only certify against generation if you're only going to use it in a case that requires generation classes. Different server operators will require different classes. So just check on your use case as to what the appropriate certification for your device is. We have a manual that is available here through scanning the QR code or on the csip-AUS.org website, which describes this in significantly more detail. So please have a read of that if you have any questions, if you want to understand more about the service, and then ask us any questions if things are unclear. And also, if there are some bits that are unclear in our process, please tell us and we'll update the manual. So now I believe I'm handing over to Mike. So I will stop sharing my screen. Sorry, we've got a question from Matthias.
Yes,
Yep.
sorry, Laura. Thanks for the presentation. I just had a quick question around the flowcharts, just out of curiosity. What sort of scenarios have you seen that would cause you to rerun the test when you are doing the witness testing? So from the flowcharts, let's say you, as an OEM, you've already done your like pre-test, so you've gone through Cactus and you've gotten all the green ticks, and then you come for the witness testing. Like, have you seen any situation that will then you to redo the test again? Yeah, despite the fact you've already gotten all the green ticks.
Yep. So they're different test cases. So the self-tests are Chapter 13 and the witness tests are Chapter 14. So Chapter 14 is tests that we can't verify using the Cactus tool itself, because the Cactus tool doesn't have the resolution to be able to determine that the inverter is doing what it should. And also we just need to view the response. So because they're different tests, the verification requires us to physically see the response. You can run the Chapter 14 tests through Cactus, and in fact, that's what we do for a witness test. We just need to view the results to be able to verify. One of the examples of some of the issues that we've seen have been ramp rates. So the tests in Chapter 14 require the server to set a ramp rate for the client and then change the output and verify that the ramp happens at the right speed. We've found that some clients don't implement ramping, so they move immediately between values, and that would be non-compliant because the CSIP-AUS standard requires ramp rates to be enforced. Does that answer your question?
Yeah, it absolutely does. Yeah, thank you very much.
Yeah, thank you. And we recommend that anyone who's doing a witness test run the Chapter 14 tests before and verify themselves that the test works beforehand, because obviously we'd prefer to only witness test everything once. So verifying yourself that the device works. And we hope to improve our website so that we have additional information on that, or example tests on our website, so that it's easier for people to understand whether their device complies with the standard or not. Yeah. So,
Thank you.
Mike, unless we've got any more questions on that process, maybe Mike, you can take over now.
Thanks, Laura. Can everyone see my browser window? Can everyone see Welcome to Cactus?
Looks good, Mike.
Excellent, thank you. So hello, everyone. I'm Mike Turner. I'm one of the senior software engineers here at ACES at ANU, and I'm going to take you through self-service testing with the Cactus app that we've developed here at ANU. So first of all, a bit of an orientation, like where are we going? So we're going to find out how to create an account and how to log in. I'm going to give you a tour of the app and how to navigate the different sections. We're then going to find out how to set up the testing. And then finally, I'm going to simulate one of the test procedures just to give you a sense of like how one of the test procedures flows. So getting started, the Cactus testing tool is just accessible through your browser. And we need to navigate to cactus.cecs.anu.edu.au, and that's what I've done here. So that's the URL, and we're on the Welcome to Cactus page. So this is what you'll see when you first come to Cactus. The first step is creating an account. Accounts are free, and they're open to anyone who wants to make one, so just need to click the login button. Don't worry that the style of this page changes. That's just because we're using a third party for our authentication. But essentially, if you already have an account, then you're going to put your details in here and then continue to log in. But because this is our first time, we need to sign up for an account. So we're going to click up the sign up link. I've got a temporary email address I'm going to just quickly use for that. And choose a password. And there's some criteria we just need to make. Make sure you make a note of your password when you create an account. Once you actually create an account, a verification link is sent to your email that just wants you to verify your email address. I won't do that now because we're already kind of like logged in and ready to go. But yeah, make sure you record your password. If you forget it, there's a forgot password link. And here we are on the home page of the app. As you can see, when you land on this page, there's a basic set of instructions to get you started. I wouldn't worry about reading all that now. I'll just remove that because that's blocking the view. This page, yep, basic set of instructions. We're not going to go in that because I'm going to go through all of this in detail. And basically, the first few steps here are all about going to the configuration page and setting up the configuration, doing the testing. So that's what we'll do. I'm going to go over here and follow this link to the config page. And this is where we set all of the options and configuration we need to do the testing. So we've got a warning at the top that we've got no client certificates. So we'll start here at the top, all about setting up and managing the client certificates. When we are communicating from a client to the server, we need to use a client certificate to make sure that the communication is valid. If we read the text we've got here, it tells us that each test will have either a device or aggregator certificate installed. A device certificate can only create a single end device whose LFDI and SFDI must match the device certificate exactly, whereas an aggregator certificate can instead manage multiple end device instances with relaxed rules around LFDI and SDF and LFDI and SFDI values. Okay, so what does that mean? Well, first of all, there's two different types of client certificates, aggregator certificates and device certificates with slightly different use cases. The aggregator certificates are intended to be used when the client is the aggregator, and these certificates allow you to register any number of end devices, whereas the device certificates are intended to be used by the end devices themselves and only permit one end device to be kind of like registered and used. That covers the first part. What about the LFDI and SFDI? So the certificate itself, the LFDI can be extracted from a certificate from the SHA-256 hash, and the SFDI is derived from the LFDI. And what this basically means is that when we are using the device certificate, the device a device registering itself with a utility service server must then use that LFDI and SFDI derived from that certificate. Whereas for the aggregator certificates, the rules are a little bit more relaxed. The LFDI and SDI, the LFDI and SFDI in the certificate doesn't necessarily have to match any of the devices registered. So when we first log in, we don't have any certificates, and that's what we're being warned about in this message here at the top, so we'll generate them. We come down here to the generate button and just click that. We've generated, at the moment, just an aggregator certificate. At the top, we get a message telling us that giving a password or a passphrase for that certificate generation, and we just need to make a note of that. This is the only opportunity you'll get to copy this password, so just make a note. I'm going to copy that into here. Back. And I could also generate one for the device certificate as well. So we've generated our certificates at this point. Certificates by default last for a year. We can see that expires in 364 days. We can now download the certificates and see what we've got. So I'm just going to click the download button. You can see in our downloads folder, we're going to get a zip file. If I open up that zip file and have a look inside, I get 3 files. We've got a P12 file, which is the certificate in PEM format. And as an alternative to that, we've got the certificate in key files, which you can use as an alternative to the P12 file. You need to configure your client to use the certificate you've downloaded. And as you know your clients better than we do, you'll need to figure out how to get them to use any certificate that you download. Going back to this page, we've also given you the options to download the certificate authority certificate should you need it. And yeah, so when running tests, the test harness needs to check your certificate is actually valid. This means that you can only use one certificate at a time, and you need to specify which one you're planning to use, whether it's the aggregator or device certificate. By default, you can see here it's expecting us to use the aggregator certificate for all communications. But if we wanted to use alternatively the device certificate, we'd have to click this button. And we see it flips to use, saying that currently we're going to use the device certificate instead. And if you have this set to device certificates, trying to use the aggregator certificate won't work, and vice versa. I'm just going to click this back to use the aggregator certificate for this demonstration. So we've now generated a certificate, we've downloaded it, and later on I'm going to simulate the client. I'll just get everything set up with certificates when we get to that point. Scrolling down a little bit further on this config page, we've got a few extra things that we can put in. So we've got the private enterprise number. A private enterprise number is a numeric identifier for an organization, individual, or other entity, and CSIP-AUS standard requires clients to encode the PEN within various requests. The PEN can be obtained from IANA, which is the Internet Authority, for free, and you can do that by following the links. So we've got a field here.
Sorry, Mike, we just had a question in the chat about how many certificates a registered user can create.
How many certificates?
Yep.
At the moment, just one aggregator certificate and one device certificate within Cactus at the moment.
Yep.
Yeah,
Josh.
I might just jump in on top of that as well. Currently it's just one aggregator, one device certificate. You can regenerate them as much as you want. The plan is, it's on the development roadmap for sometime in the near future to move the certificate management to live underneath the devices that you're testing accounts. So instead of having one cert that's global to your user, it'll be dependent one set of certs for each device. And it's also worth noting that if you have been using the tool up until now, the certs are just they're self-signed, but they will be in the process of getting swapped out at the moment to a full 2030.5 compliant signing chain with a circa MCA mica for everyone to sort of manage. Sorry, Mike. I'll
no, all
be
good.
quiet
Thank
now.
you, Josh, for that. If your organization, so this is back to the private enterprise numbers, if your organization doesn't have a pen yet, or you've applied for one and are waiting for it to come through, don't worry, you can leave this field blank. It doesn't stop you doing some testing. It doesn't stop you starting tests. You'll just find that some of the criteria don't pass because it's expecting a pen as part of the validation. Moving across to the right, another value we can put in is the subscription notification domain. So the utility server can either send out notifications about events that are happening, or as an alternative to sort of polling that server. And as part of that process, you register to receive notifications with a particular subscription URL of your choosing. But there's a constraint there's a constraint there, which is like there's a URL. Let's read this out. The domain will be authorized for receiving the subscription notifications. Attempts to register notification URIs outside this domain will be rejected. So you have to essentially put in the domain of the subscription URL that you're expecting to use, and a check is made against that. I'm not going to do any tests using subscription notifications in this tutorial, so I'm going to leave that blank for now. Although I have forgotten to go put in a news pen. I'll just quickly do that. Because I do have that, and I'm going to use that. So we've got a field for inputting the pen, and we just have to remember to click the update button to make sure it gets saved. Moving over to device capability URI. So the discovery process that begins all tests and in principle all interactions with the utility server is a request for device capability. And you need to know what the URI is that you're going to use to do that. As we shall see later when we're testing, each time we create a new test run, we're given the device capability URI. This option controls exactly how that device capability URI is generated, and there's basically two options here. There's a static option, and basically this means that that URI doesn't change, and it's reused across all test runs. The other option is a dynamic URI generation, where that a unique device capability URI is generated for each and every test run. As you can see here, currently it's dynamic, so that's the default, so a unique URI is generated for every test run, but we can change that by clicking swap to static. We're now set to use a static URI, and in fact it gives us what the URI is for the device capability endpoint just beneath it. There's sort of some pros and cons to those two options. The static URI means that you can only run one test procedure at a time. There's no way to run any in parallel. But it makes it easier to set up your client because there's one URI that's constant, and you just need to set it up in your client, and you're probably good to go. Whereas the dynamic one allows you, the benefit is that it allows you to run multiple tests in parallel, but you've just got the added extra step of always having to set up each client with the dynamic URI that gets generated. There's no right or wrong here. You just have to decide what's going to work for your particular use case. So everything on those three, and then moving down to the bottom, run groups. Finally, at the bottom, we've got the run groups configuration. And before I get into run groups, I'll just check that we know what we mean when I use the word sort of test and run. So when I say test, it's short for test procedure. These are the things that are described in TS 5573, and they have names like All 01 and Gen 03, and comprise of steps to be followed and criteria to be met. A run or a test run is a particular instance of a test where a client is being tested against a test procedure to determine whether it complies or it doesn't. Okay, given that, we get to run groups. So run groups solve the problem of separating test procedures for different devices, essentially. You may have more than one device you want to test, and you don't want all of the test runs to be muddled together. And so we can create a different run group for each of the devices and kind of like just basically keep things separate. And as the name suggests, it's simply a group of test runs under a given name that we get to choose. Run groups also have another purpose as well, a sort of secondary purpose. They allow you to choose which version of the test definitions you want to test against. So at present, there is version 1.2 of the test procedures published in 5573, but there's already work on a version 1.3, which has test targeting like battery storage. So you can choose to assign a particular test definition to your run group. By default, we get a run group created for us just called default group, and we can see that it's targeting the 1.2 version of the test runs. There are no test runs been performed with this run group yet, and then there's a button for deleting them. So you can create as many run groups as you need. So let's imagine a scenario where we've got 3 devices, and so it kind of makes sense for us to create 3 different run groups. So I'm going to rename this first run group to device 1. Accept that, and remembering to click save so it gets remembered. Just scroll back down again. And we've got 2 other devices, so let's create a new 1.2 group for the second device. Oops. Remembering to click save. And for whatever reason, our third device we may want to test against, it might be a battery, so we might want to test it against some of the battery storage tests that are being developed. So do a new run group for the 1.3 beta. Device 3, and save that. We can see that scrolling down, it's targeting 1.3 beta, the storage tests. And then maybe later that device gets decommissioned, or we regret creating that run group, so we want to delete. When we click delete, it's very important to realize that once you delete a run group, you delete any test runs associated with it. It's sort of a very big caveat. Well, we've got this sort of big warning here. So, for example, if I've done a series of test runs with that group and I then click delete, I'm going to also lose access to all of those runs. So that's one thing we just need to be careful about. In this case, we didn't mean to create that run group, and there aren't any test runs we're going to lose, so we're happy just to delete it. Rightio, that's all of the settings. Does anyone have any questions about that at the moment? Take silence as a no. So we've got everything set up. Let's have a look at the test procedures themselves. So we've got a page here with a link called procedures, and this gives us a nice table with a list of all of the test procedures, giving their name, a description, and what category of test they sort of fall under. Just sort of scroll down and there's quite a few of the tests. Clicking on any of the test procedure names links us through to its definition. So for each test, we have a codified way of describing what we expect the test to do. I'm not going to go into this into too much detail, but we've got a bit of metadata at the top. Some tests have preconditions that must be met before the test can start. We've got a description of the criteria, and then the steps themselves. If you want to find out more about the format of these test procedures and what all of this actually really means, you can click this link at the top that's available on each of the test procedure pages, and that takes you through to our GitHub repo for the test procedure definitions themselves. And in the README, there's a full description about the format of those files, what it all means, and what the kind of implications of everything is. One thing I will highlight, though, is that at the top of each of the steps is a little comment that links through with letters on. These letters actually refer to the steps as they're outlined in the actual standard TS5573 itself. So I'm just going to jump across to that standard. We're looking at all O2 at the moment, and if we scroll down, we've got the actual test procedure itself, and we've got the letters A, B, C, D, and E. So these letters here that describe the steps in English language are also kind of like referred to, there's a cross-reference essentially. So if you're wondering the steps here, what do they actually correspond to in the actual test definition in TS5573, you know how to kind of make that link. Back to the procedure page. I think that might be everything you want to do on that. Yeah. The final main page, and probably the most important page, is the runs page. The runs page is where you find out what test runs are currently active. It's where you go to launch new test runs, and it's where you go to look back at any sort of previous test runs and look at their results. And so essentially, it's the main way you interact with Cactus and the test runs. If we look at the top, notice it says runs for device 1. And you may remember that we created some run groups in the config page. So this is what allows us to choose different run groups, and essentially tells us like what's potentially what device we're testing, what run group we're actually working at. I'm going to leave that on device 1. The page is structured in such a way that we've got a left-hand bar for selecting things and a right-hand main area showing you what's selected. For the moment, we've got active runs selected, which is, well, we know that because it's in blue. And on the right-hand side, it's telling us there aren't any active runs. And that makes sense because we haven't actually launched anything just yet. Beneath the active runs, we've actually got a sidebar listing all of the test procedures in 1.2. And you can scroll down. It's quite a long list. You can scroll down and you can see all the different test procedures grouped under the different categories. You can close them up just to save space if you want. This is one way to shrink the list, but we can also filter the list as well just to show certain compliance classes. And this relates back to what Laura was saying about the different compliance classes for different device types. So for example, if we want to see, we can turn off, I need to open this. Let's back up so we can see it disappearing. This allows us to filter this list and just see particular compliance classes. So I can sort of turn off different categories of compliance classes, and we can see the list over here updating as I do that. And that allows us just to narrow in on particular compliance classes if that's what your interest is. I can select all, I can select none, and then just select, for example, the tests that are related to subscription and notification functionality. I'm just going to leave that on show all. So that's one way to filter these tests, to see tests just based on compliance category. When you click on one of the test procedures, you get its name, a short description, and you've got a link through here which takes us again to the test procedure. You can check it out. Most importantly, this is where the launch test button is for starting a new test procedure. Scroll through my notes and check where we are. So at this stage, we've covered creating an account, we've done logging in, we've done setting the configuration, and we've toured the main parts of the app. And now we're kind of ready to like run a test properly and see how it works. I don't have a real client to use the test, so I'm going to simulate one using a generic API client called Postman for sending the requests to the utility server. So I just need to do a quick little bit of setup for Postman. First off, I need to set up Postman to use the certificate that we downloaded. So I come to certificates. This isn't strictly relevant to testing with Cactus, but you may find it interesting if you ever want to do it this for yourselves. Copy some values. I'm going to use the CRT file. CRT. Select the key file. If I were to use the P12 file, I would put it in where this says PFX, and I'd also have to remember to put in that passphrase that we saved earlier. So we've now got our certificates added into Postman for doing the requests. And the other part is I also need to use I haven't saved it, the device capability URL. So go back in here, go to config, come down here, and I've got that part. So I've set up all of the requests that I need to make during the all O2 test. There's a whole series of requests that I'm going to need to send, and I've got them all set up. And essentially, that host variable is just a variable that substitutes in the URL that I need to use to talk to our server and with the device capability on the end. So we're all set up. Switch back to Cactus. I'm going to go back into runs. I'm going to do the all O2, and I just have to click new test run to set everything going. The spinner spins to show that it's working, and each test run is completely independent and isolated from all other test runs. And what this means behind the scenes is for each time we start a new test run, we're spinning up a new utility server, we're spinning up a clean database, and we're spinning up all the other test run infrastructure that's required. That's quite a bit to do. It typically takes about 20 seconds for that all to be spun up behind the scenes and be ready for us to use. We just have to be patient. But when everything is ready, we land on the run status page. That should happen any moment now. A few more moments. Some of you all are experimenting with Cactus yourselves. Perhaps there's a bit more load on the server at the moment. There we go. So this is the run status page. A new run has been created, and I'm going to go through what all of this means from sort of top to bottom and explain. Starting at the top, each run that we start gets a unique ID. In this case, I've got the exciting number 999. That's purely an accident. It's telling us that the test has started. Again, we're given the device capability UI, and we know that we'd already set the configuration to use a static one. So it's, for those who are eagle-eyed, you'll recognize that as one that we've seen before. This is a live page, so it updates as the test procedure happens. The information on this page changes. So at the top, we've got an overview section telling us that we're doing all O2. Tells us when the test was started, when it was created, and when the last interaction was. The last interactions typically tell you when the last time the client sent something to the server, but when a test is also started, we get a timestamp just for it spinning up, and that's considered the first client interaction, if you will. We have this nice summary line that's telling us that we haven't completed any of the steps, which is what we expect, because we haven't done anything yet. Some tests have preconditions that have to be met before the test can be started. All O2 is one of the simpler ones. It's basically a registration test in which we do an in-band end device registration. Scrolling further down, we've got the criteria that must be met during this test. We've got all steps complete, which is basically part of every single test, but you have to complete all of the steps to consider to pass the test. And the red cross tells us we haven't done it yet, and it's telling us that these are the steps that haven't been completed. We also, because this is an in-band device registration test, we also need to have, we've got criteria around creating an end device and also setting the DIR capability, the DIR settings, and the DIR status of that test. And again, red crosses tell us we haven't done that yet. The next section tells us the steps that make up the test procedure. So we've got 5 here. We've got get device capability, get end device, get the time endpoints, post the end device, and then get the DIR list associated with that endpoint. The little blue play icon is telling us that it's expecting us to do this step first, and it's not paying any attention to these other steps. It's waiting on us to send the device capability, or request the device capability, should I say. We'll see the timeline a bit later on as we go through. So our test started, we've got everything running. I now need to start completing those steps. So I'm going to switch back to Postman. And I've got my steps sort of set up here. So if you remember, the first step was to request the device capability. So I'm gonna send that request. We see the response we're getting back. It's a 200, everything's good. Let's have a look at how the status page updates. We can now see that the last interaction with test harness was just a few seconds ago, because we just sent that request through. We now see that we've actually completed one of those 5 steps. We still haven't completed any of the criteria, but it's now recognizing underneath the steps category that we've completed get device capability, and that's to be expected because we've just sent that request. Beneath that, we're seeing that we've now got play symbols for the get edev and the get time. Essentially, we could choose what order we do these. It's waiting for either of these steps to happen. It's not waiting for these steps to happen. And we see on this lower section here, this section here tells us all of the requests that server has seen. It's seen a request for get device capability. The response was 200. That request contributed to the step gets decap. And we also are told that the request body was valid, that the XML was valid request. And we're also getting a bit of information from the utility server itself. That's what Envoy is. It's our utility server. And it's telling us that it received the GET request for device capability. So all going well so far. Let's do more of the steps then. Let's switch back to our clients. I'm going to move over to the second request, which is get edev. I'm going to send that. We're getting a response. It's the end device list. Some of you may be wondering, you can see in this end device list, we've actually got a end device already present in the server. And yet we haven't created one, like what's happening there. The reason for that is I've elected to use a aggregator certificate. So I'm behaving as an aggregator. And for all aggregators, there is a virtual end device created with ID 0 for that end device. And essentially that's what we're seeing here. So this is the LFDI and SFDI of the aggregator. And so this is created automatically for us as a virtual end device for the aggregator. It's not the end device that we're going to be registering in this test. Switching back to our status page, interactions updated. We've now done 2 of the 5 steps. We still haven't completed any of the criteria. That's fine. We've now got a green tick for get end device. And now we can see that the get time step is active and the posting the end device step is active. So we could do either of those steps next. Again, this is all updated. We did a GET request for the EDEV, and that's now showing up with a 200 and that the XML is valid. So let's move on to do the next step. Get the time endpoint, get the server time. Again, there's a 200 response, everything's happy. Switch back to the status page. Again, it's updates. 3 out of the 5 test steps are complete. We've got the time step complete, and we've got the time endpoint showing up here, so that's all good. Things get a little bit more interesting now when we move to the next step, which is creating the end device. We've got a post request set up here, and I have pre-populated the body of the request with a LFDI and SFDI. The LFDI needs to have the PEN, the private enterprise number that we're configured to use, and so I've already set it up to use ANU's PEN here. And the device, I've just chosen a water heater, so that's what we'd expect to see. So we send this request. We get a 201 created, so something went right. Now I'm going to switch back to the status page and see where we're at. We've got 4 out of 5 steps complete. Excellent. We've now got a tick showing up for one of our criteria that we're currently at. So we've got the end device has been created. We've got a tick for the post end device. We just did that step. Scrolling down, we see our request. We've got a post to the end device. We've got a 201 created. That completed the post end device step. However, there was something not quite right about that request, and we've got some XSD validation errors in that request. Not going to go into that right now, but essentially, this is one of the ways in which you can be informed that something's not quite compliant about your client in the way it's communicating with the utility. So we'll have a quick look at that towards the end when we look at the PDF reports. If we scroll back up to the criteria, not only do we have to create the end device, we've also got the requirements that we also need to specify the DIR capability, the DIR settings, and the DIR status for the end device. This is kind of almost like implied in the standard, so it doesn't actually correspond to a particular step in this, but essentially we need to do some put requests to supply that information to sort of fill out the details of the end device that we've just registered. So I've got these all set up. I've got 3 put requests here. The first one is specifying the device capability, and I've just chosen some values here, just representative values. Send that. I get a 204, which is still a success. We've got another request. This time it's putting the settings. I just want to draw your attention to this particular value. This is the max power. So the max power is sort of the nameplate rating of the device, and we've got a value of 1,000 to the power of 10 to the 1, which is multiplying it by 10. So that's 10,000 watts or 10 kilowatts as the max power for this device. I'm going to send that. And then I'm going to also send this final put request, which is for the status, so the status of the device. Send that through, and then switch back to Cactus to look at what's changed here. We've got about 5 steps complete. You now see that we have satisfied the criteria for the DIR capability settings and status of the end device. That's great. No real change here because those criteria didn't really correspond to a particular step. We're kind of implied. Interestingly now, we've got, there's not much really to see in this timeline. Mehdi's going to show you more of the timeline in his witness testing. But essentially, it's recognized that the device has a maximum power, and it's conveniently drawn the limits of the device. So we know that the power values should be kept within those limits. So that was the 1,000 times 10 to the 1. Again, we've got the requests themselves. We can see what endpoints we hit. You can see we had a successful status code. I didn't correspond to any particular steps. That's fine. But again, there's something not quite right about those put requests. There were some errors in the bodies of those, and we'll have a look at those later. Moving back up, we've got one more step to complete get DR. So let's go and do that. Set that request. We get 200 OK. We're getting the expected dir list response we expect. That have the links that we'd expect. That's looking good. When we switch back, and we now see 5 out of 5 steps complete. Got green ticks showing us that we've met all of the criteria, steps, completed all of the steps, and we can now see that that particular request was both successful and it was a valid request. So that's great. So now we've basically completed the test and we need to finalize it. And I'll just do a quick aside about finalization. So finalization is the process of finishing the test. A few things happen when we finalize a test. A PDF report is generated detailing everything that happened during that test. This PDF report is included in a downloadable zip file that also contains some other log files. It could be useful for diagnosing problems with non-compliant behavior. Also, when we finalize a test, all of the infrastructure, the utility server, all the other bits and pieces that were spawned at the beginning of the test in order to be able to perform the test are all down, and the test is terminated. And so once that's done, basically we can no longer send requests through to the test because there's no infrastructure behind that. There's a few ways in which we can finalize tests. The first is by manually finalizing the test, and that's by clicking this finalize button. We can do that. We typically would do that once we'd completed all the steps of a test. But we also may decide like something's gone strange during the test, and you can finalize at any point basically. So if something's your client's not behaving the way you expect, you're seeing some funny results, you can terminate the test early by clicking that finalize, and then you can kind of dig into what's happened, and you still get access to all of the logs and the files. The second cause of a test finalization is some test procedures expect the utility server to receive readings at particular rates, and if the client that doesn't meet those, it doesn't meet that minimum number of requests per second, then the test also gets finalized, a kind of like termination because one of the criteria is not met. And then the final reason is that if there's a test running but the utility server hasn't received any requests in the last hour, the test run is basically deemed to have been abandoned, and we basically pull everything down just to keep everything tidy, just so we don't have lots of long running tests hanging around that are not being used. Okie dokie. Gone through testing. We've done everything. We're now on to the final stage. So I'm going to click finalize on this. It takes a few moments to generate all the files. And we'll see that a download will be automatically triggered containing the artifacts of that test run. Go into that and open it. It's artifacts. Have a look in here. Oh, thanks for that. So if we open up that zip file, we see a number of files, the most important being the PDF reports here. That's got the most information in it. Which we'll come back to, but there's also various log files in here. So we've got the Envoy server log, which is the log file generated by the utility server during the test procedure. We've got a log file of any notifications that were sent. That's going to be empty in this case because we weren't using subscription notifications. We've got a dump of the database that the utility server maintains. We've also got a JSON file that contained a summary of, more or less a summary of the data that we were seeing on that status page. And finally, the runner itself produces a log file of all of its interactions, what it observed as the test goes along. In general, you probably won't need to use these if everything goes well, but they could be helpful in us or you diagnosing what went wrong during a test procedure. But the main thing we should be looking at is this PDF. So I'm going to open that up. So this is a detailed report showing everything that was recorded during the test procedure. In effect, it's a more detailed version of that live status page. At the top, we see which test was run and some of the details of the test. So we were running all-mode 2, and that description of discovery with embedded registration. We've got some version information over here on when the report was created. There's our run ID, there's the aggregator LFDI, the pen that we used, some time. It took us 12 minutes to do that test. Just some summary information. The report's broken down into various sections. At this top, we've got the criteria section. So we now see that there's, in effect, there's actually 6 criteria that we had to meet. We saw 5 listed on that status page, and they're really like the main criteria for the test procedure, but there's also an implied extra one, which is that all of the requests had valid XML bodies in them, and we know that in the case of the post and the puts, that there was something not quite right about those. So although we passed all of these, we failed 1. And for any failure, we've got a little summary line telling us that for that particular failure, it detected 8 XSD validation errors, and that happened over 4 requests, and that's what we expect because there was 1 post and 3 puts. Further down, it actually details what those XSD validation errors were, and we'll get to that in a little bit. The next section is a kind of Gantt chart type thing that shows us what happened during the test. Essentially, we've got time along the bottom relative to the start of the test. We've got bars for each of the steps that we were part of the test procedure. We've got some sections up here. So as we can see, there's a key at the bottom which explains what each of the symbols means in this chart. So we had a GET request to decap, and we can see that that corresponded to that was received towards the beginning of the test, and that corresponded to completing the GET decap step. We then had a GET end device list request, which we sent next, which corresponded to the GET EDEV. Then we did time endpoint. Then we posted the end device, and that corresponded to the post end device step. We also did 3 put requests for the device capability, the device settings, and the device status. And those didn't actually correspond to any particular stage, and so they get put in a section that's in gray here called unmatched, which is any requests that the utility server received but didn't contribute to any of the steps. And then finally, we did a get the dir list for the end device, and that was the last request we sent. This section at the top, some tests have preconditions before the test starts proper, and essentially this records what requests were sent in that sort of initialization phase before the test is actually started, which we didn't really have in all-mode 2 because it didn't have any preconditions that needed to be met. In the communications section, we've got this histogram which shows you during which time windows we saw how many requests. So between 200 and 400 seconds into the test, we received 2 requests. Between 400 and 600, we received 3 requests. And 680 seconds into the test, we also got 3 requests. This is supposed to give you just some sense of like the number of requests, how they're happening over time, and to see whether your client is being responsive or not. And it'll probably be more helpful in situations where there's regular readings being sent. Here we get to the validation errors that we saw earlier, the XSD validation errors. So it's recognized that in the post, the 3 puts spills off into the next page. Apologies, by the way, it's quite tricky to do dynamic generation of the PDF, and so you can see that there's some errors in layout of the document. These are all going to be fixed soon enough. They're all sort of in progress. Don't worry about the fact that at the moment some of the text overlaps. That's all going to be fixed, which makes it a bit tricky to read. All of these little rough edges that need to be tidied up. I'm still not going to go into this into too much detail, but essentially what we're seeing is that when an XSD error crops up, it could be due to there's an extra element being sent, so we're passing more information than what we should be in the request. There might be complaints about missing elements in the body of the request, and sometimes it might be that the data type of the value that we're sending in that request doesn't match what it should be. So that's broadly speaking the 3 sort of types of XSD errors we see, and you can read through this if you see them yourself, and it's a more detailed explanation of like what those XSD errors actually are. The next section in the list is devices. We registered an end device. It was a water heater. We've got its LFDI. We didn't specify a NIMI for it, and then we've got a whole table of the ratings. Ignore the fact it says none to the power of 10. That's basically telling us that we didn't set that value, and in a future release, we're going to have that not shown at all. Another rough edge. So tables of all of the values that describe the device that we registered. If we were doing a test that involved readings and DOEs, then we'd get an absolutely beautiful chart here showing that draws graphically a chart showing the DOEs and the readings, and that helps you judge whether the device is responding correctly. And if we'd had readings, we'd also have tables of the readings that were sent, which we didn't have in this particular example. All right. That's the PDF report. So as a wrap up then, we've now had a tour of Cactus. We've seen how to get logged in and set up, and we've just done a run through of all O2 using Cactus. You should now be in a good position yourselves to perform self-testing. Thank you for listening. Now I'm ready to hand over to Mehdi for a discussion of witness testing. I'll stop sharing.
Thanks, Mike. Hello, everyone. My name is Mehdi, and I'm the lab manager and technical officer at the ANU. At the moment, I am the contact for OEM onboarding for CSIP-AUS certification service we have launched recently, and also we'll be conducting witness testing at our end. So I'll talk through the witness testing requirements and the electrical setup, and I'll try to run a half-live demo using one of the DR lab setups that actually integrated with a client and a PV inverter. So let's get into it. I'll share my screen now. Can you see my screen? Witness testing. As I said, this is the part that we think that the OEMs really need ANU involvement. So far, Laura talked about the overview of the certification process that we have developed at the ANU, and Mike gave you detailed description of how to register on the Cactus platform and conduct self-testing at your time, basically. But the next step for the OEM certification will be witness testing, and so I give you an overview of that. The tests under the 5573 standard are categorized into different sections with different requirements. Section 13 are the self-tests that client that can do at their own time, and it's basically the testing that comes between the client and the server. Section 14, on the other hand, are the tests that require a DER as an end device and testing the behavior of the DER, which is under the control of the client. So as I said, like section 13 are performed by the client as self-testing, and they can provide the reports for us as a proof or provide the run numbers, and we can check at our end. And 5573 standard doesn't specifically define witness testing, but for the purpose of the ANU platform, we have developed this framework, because section 14 tests are the tests that need to be partially or in full executed, observed, and captured by an independent operator or tester to be verified. And this scope may be reviewed in the future. We may be able to offer even the chapter 14 tests as part of the self-testing if we can automate everything and data capturing. There are also section 15 tests that may need involvement of the ANU, but we are in the process of clarification whether or not these tests actually need to be supported by the ANU. But the Cactus platform already supports those tests if anyone needs them. So there are three communication paths possible, and more actually, under the 5573 standard. The first one is the DER device can directly be controlled by the utility server. I haven't seen this model yet, but there might be some cases. But the other two we have had in our lab, and the middle one is the one that I'm gonna demonstrate for today's presentation shortly. And it's basically DER under control of a gateway or controller device, and at the other end, it's integrated with the utility server. It's possible that a DER is controlled by a cloud platform, which we have one case in the DR lab. In all these models and more, there could be other models that can control the DR through cloud gateway combinations. Under witness testing, we need to study the behavior of the DR and verify it against the standard. And this is the part that not specified in the standard in full, and may need some discussion with the OEMs in terms of the pass-fail criteria. And I will talk about it in a while. So we have a technical group to discuss this, and Laura mentioned we have an issue resolution pathway when it comes to interpretation of the standard and maybe various interpretations. So under section 14 of the standard, we have these tests listed. As you can see, three main categories. All DERs need to pass these 5 tests, starting with all DERs capable of generation, which are basically PV inverters and similar, need to pass these 5 gen tests, and DERs capable of consumption, such as loads, smart loads, or bidirectional EV chargers, need to pass them all. Or if they are only smart loads, they need to pass the load test, not the gen test. This electrical setup is one of the requirements that we would ask the clients to prepare before witness testing. And basically, it needs the client to be integrated with the Cactus, which is the primary requirement for all tests. Also, the client needs to be integrated with one energy meter at the site or connection point site. But we will need 2 more meters, which are important for the client to provide for witness testing, and they will independently read the DER and cite basically power flow. Another requirement is a load in parallel with the DER, which is capable of at least 50% of the DER generation. On the other side, we will need a DC source, which could be an actual PV or simulated PV. We have seen problems with using actual PV for the test, and the test needs the DR to be generating or consuming at least 50%. So if we want to use PV, we should make sure that we have enough PV on the day. If you have solar simulation capabilities at your lab, that's much preferable, and that's what we are using today for today's test. And obviously, we will need an AC source capable of importing and exporting. One important capability that we will need on the testing day from the clients to be provided is visibility to these independent meters. We can read the client's meter through the server, but we need through a video camera and an online call. But we encourage OEMs to provide a meter with data logging capability, that we can log data as we test, and they can provide a copy of the data captured as an evidence. So that this is also something we will need to kind of refine with the clients, because some of the tests are new in the new version of the standard with more strict requirements, such as ramp rates. So it will be good to have the proper gear for this. So what's the framework of witness testing? Let's review that here. When you pass the self-tests using the procedure you just heard about from Mike, you're ready to request a witness test by contacting us at this email and provide the required information. We will send you a form for you to provide us the required information, such as the company information, the devices under tests, and firmware information, site power model, and accuracy. One important aspect I forgot to mention, maybe I can go back to this slide, is the accuracy of these meters. And based on the 5573 and 477 standards for power reading, the required measurement accuracy is 4%. So that's something to have in mind. So as a proof, we may need to capture the power meter models and just use the datasheet or other means to validate that. And using the description Laura gave you about the class test, and you can find it in the manual about the tests and different classes. We need to clarify what tests you need to pass. And then you can run and verify chapter 14 tests at your end without our involvement as a precondition, and you can validate them. And when you are ready, we will give you a time slot to go through the test. For the day, you need to provide the electrical setup. Yep, that's it. So for today's demo, we thought to go through one of the more interesting and maybe challenging tests and showing a live demo using the catch power and SMA setup we have in the DR lab. So those groups helped us a lot to prepare this. Well, I must say that the catch power device is not developed against the new requirements, so it's not complying in full. But it's interesting to see how it follows the export limits, and we will look at the ramp rates together. So basically, from the test I listed, let me go back here. Some of them look to be straightforward, and it's just like one energization or disconnection command and see the behavior, but this ramp rate needs to kind of adjust the export limit and also ramp rate values through two parameters, which is ramp TMS and set grad W. And then we will evaluate the DR behavior. This is kind of a graph that I tried to put together to help the performance, to help to validate the performance of the DR. And if you look at the standard, it's setting the ramp rates values somewhere here, but before that it uses the default value, which is 0.27, sorry, I had it somewhere, 0.27% per second. So for a 20% drop, it is around 74 seconds. The other values are described in the standard. For example, for this step of the test, the set grad W is set to 1% per second. So it means that for a 30% jump, we will expect 30 seconds. And this is the kind of setup we have in our lab ready for the actual test. I have run the test yesterday, so it takes a lot of time and we need to look at different variables. So I will just run through the beginning of the test live, and I'll then show you a recording of what we have from yesterday. And this is part of the reports. Mike just talked about it, how this is an interesting one, to be able to monitor the DR commands or DR controls as they sent by the server. And we will validate the DR behavior by capturing the basically power. So we have power meters in our lab that can log the data as we run the test event, and that's what's used for the for this test. As you can see, the ramp rates are not yet developed for this client, and it's interesting. Although it's following the export limits, it's not responding to the ramp rate commands completely. This is a 8 kilowatt inverter, so we had these set points. 50% is precondition. We are not too worried about that. We have 30% jumping to falling down to 10%, going back to 50%, and then 0, and then 30%. So we can see that 30%, 10%, 50%. It's following the exports, but it's not complying with the ramp rate. So I will get to this shortly. Just give me a few minutes. If there is any QA, Laura, feel free to moderate that so I can prepare the live demo. Thanks.
Thanks, Janus. We're doing this test at the moment in our DER lab facility here at ANU. Most of the witness testing we expect will be done remotely in line with how SAPN has done it previously. But we have installed a few devices in our lab on request of the OEMs in question. And ongoing, this is something we can do on a cost recovery basis, so we can't put that as a free service. But if you'd prefer to do the testing have the device in our lab, it's possible.
Yeah, so this is the interface. We could see that I have configured my Cactus interface as Mike just described. So I have generated my certificate and everything. And so I have this set up under catch control, and I can create, so I can come to this listing and choose DER tests if I want to, or I can just do that manually. Anyway, so all 28 is what we're testing. I just created a new test run, and it takes a few minutes. So if it's taking too long, I'll just quickly switch to my recording. But it'll be interesting to see the live performance of the DR. I have the SMA inverter waiting basically for commands, and we have the catch power interface, and also my solar simulator is ready. I just need the end device to be registered here. Sometimes it takes a lot of time based on the CSIP-AUS service of the catch power service. So in the meanwhile that this is getting ready, maybe I'll switch to my recording and I'll come back to this when it's ready. Can you see the recording?
Yep.
Thank you. Yeah, so this is basically what I'm doing in the background. I create a new test run.
Do you mind maximizing that screen, Mehdi, so we can see it better?
Yep, sure. I
Yes,
wanted to
yes,
keep
we'll
an
do.
eye on the other screen, but I'll do that now. Is it better?
Yeah, perfect.
Yep, yep.
It's better.
So this is what I'm just did, creating a new test, and also, sorry for the clutters on the screen. So I ran this a few hours ago. One thing we realized is that the preconditions in the standard may not be implemented in full. So this is something we will look into. It could be just a verification. So the standard for most DR tests requires a 50% export or if I just pause this when I'm talking. And at the moment, this precondition is not met. If I go back here, you can see it's 800 watt, but this is not, we want to validate, we want to validate ramp test. And you can see that in my test case, it's obtaining the end device information. So you can proceed with this. This is the interface we have for our kind of energy meters, and it's a very capable interface that allows you to capture live data as we run the test. So at the moment, it's looking at the DR side of the test loop. And I have set it up so it's capturing all the data as we run the test. So I have received these green ticks. I'm ready to go. And as part of this test procedure, it creates 3 DR controls, which are basically 30%, 10%, and 50% of the export limit. And then default grad W, which is adjusting the behavior of the ramp rates. So as you can see, it has started the test. Here we can see the export limits sent by the server to the client. This is the client server. This is the DR behavior. So we are basically waiting for the client to receive the first set point. In the meanwhile, I'll just, so what we are emulating is this graph. So we can see that it has received the first 30% set point, and it's trying to match that. So this is live, the solar simulator. And these platforms have some delay. And the energy meter interface I showed you is real time again. So we can capture everything from this interface later on as we are running the test. So it's looking at this. So we have consistency between this and this, which is the solar simulator. So we can see that it's following the first set point. And the server has sent the third DR control. We can see 800 watt limit has received at the client, and it's followed by the DR. I will fast forward a bit. Yeah. And the other cool thing is that Cactus emulates the command as they go. So you could see like 30% and 10% set points sent by the server. Server doesn't verify the DER behavior. So that's why we have this witness setting, and the 50% set point has been sent. I should have said that the DR on the test is an 8 kilowatt inverter. So 50% is 4 kilowatt, and it's matching the command. We can see here that the 4 kilowatts set point has been sent. This UI has a bit of delay, but we can see that it's matching here, and this is our live monitoring platform. So here, as part of the procedure, server cancels all active DR controls, and what that means in practice is that the default, and it goes to the default value, which is 0. So yeah, the 0 command has been sent. Let me maybe put back this on the screen. So this is the waveform we are building. So we are here at 0. And server has canceled all DR controls, as I said, which is basically using the default, which is 0. And maybe I'll fast forward a bit here. It's 0, 0. And at some point we expect it to come back to the 30%. Yep, it's there. So after 0, it jumps back to 30%. And at each phase, it adjusts different values for ramp rate. So that's why we have different steps. And it's coming back to 2400. Yeah, so this is my interface. I ended the test here, and it generated all the reports for me. So now maybe I can just quickly jump to the reports, which I have generated here. Yeah, I have received live green ticks for this test, so I could have started, and I was lucky with run number 1000. So maybe I'll just run this one in the background. And yeah, this is the test generated. So you can do this part at your end even before contacting us, and it gives you all the validation data you need. The main piece that I will be looking at is the behavior of the GR. So I have logged the data here, and it's just this tool gonna plot that power waveform for me. And this is it. So it's interesting that it's following all the commands, but ramp rates are not implemented. So maybe just let's look at one of the ramp rates. So from 10% to 50%, let's open this. So we expected from 10% to 50% within 60 seconds. And it's not quite following a ramp behavior. It's just 3 steps. And it doesn't follow that 60 seconds. So it shows that the ramp rates are not fully implemented in this client, which is normal because, as I said, this is not developed against the new platform. It's tested against the current or older version. Should I say older or current? And yeah, I think that's it. This is the piece that I will verify the behavior. As you can see, for the falls, it's very fast from within less than half a second. So it means that the ramp rates are not implemented here at all. Yeah, I think that's all from me. Sorry, I missed the questions as I was focusing on my screen. Is there any question for me, Laura, or you?
I think I've answered the questions that are coming to chat as they've come up. Yep. So the questions we had were about the lab. So it doesn't matter where the lab's located. We just need to be able to see the device response. So I guess the biggest constraint overseas is trying to find a time which there is sun in the client country and is hopefully not 1 a.m. for us. But we manage that in the same way that South Australian power networks do. So, you know, testing late in our or early in our day is okay by arrangement. So I think we talked about the lab. We can host devices in our lab, but we expect that most people will use their own facilities in line with what South Australian power networks did. The power meter, there are some accuracy requirements in TS-5573. I don't think they're particularly onerous. One of the key parts is that TS-5573 has ramp rates in it, and that wasn't something that the previous version tested for. So the 2 ways we do this is if the meter can log to a CSV, you can send us the CSV, and that's the best way to do it. If not, we record the witness test, and then after the witness test, we'll just verify the ramp rate from the recording, rather than it's hard to do that kind of thing live. And yes, as Josh said, all witness tests are available in Cactus. You can run these witness tests by yourself and verify that your device complies before you do the witness test, and we definitely recommend that you do that just to make sure that hopefully we only have to do 1 witness test per device. Mehdi, was there anything you could add to that?
No, that's all good. Yeah. I think when the clients reach the point that they want to do witness test, it means that they have passed section 13, which means that all the comms between the client and server is being verified. For the DR behavior, they can verify that at their own lab, and when they are confident, they can contact us for witness testing.
Any other questions? As I said, if questions come to you later, feel free to email them through to our support inbox, and we'll get back to them. I expect that we're going to have a fairly high volume of inquiries over the next week, so we do apologise if it takes a little while to respond. And also, this is our first runs through with this new procedure. We've tested it in development, but there may be some teething issues, so you may need to bear with us a little bit if some issues come up that we need to resolve. There have been some people who have already been using the test harness, Cactus test harness and test witness tests over the past little while. So just a note for anyone who starts testing today, on the 1st, we will refresh Cactus with the most current version, and previous test results will probably disappear. So don't do anything that you really care about the result for until the 1st, so the day after tomorrow.
Cool. I can see run number 1000 is passing all the tests, but it's basically the same thing I showed you.
Yep. And yes, Peter's right. We're always happy for people to come and have a look at our lab. It's something we're quite proud of. So particularly the power monitor that Mehdi was showing, that's one that we've built in-house. So that's always a nice thing to show off. Right. So I'll take this as we don't have any questions at the moment. As we mentioned, this recording will be posted online on the CSIP-AUS website after this event, and you can review that recording whenever you like, and you can email us with any questions or comments. If we receive the same question quite often, we will add this to our manual law and FAQ section. For example, the test classes discussion we had was in response to people asking us what test classes to use. So please don't hesitate to ask us questions, or if you find bugs or you have issues, please reach out to us, because this is how we make the service better.